Picture this. The clock is relentlessly ticking down in the exam hall. It's so quiet you can hear a pin drop. You turn the page of your Cambridge IGCSE physics paper, syllabus code 0625, and boom, there it is, the dreaded multi-stage extended response question on alpha particle scattering. Your heart sinks a little, right? Because look, you know the science. You have literally memorized the textbook front to back. But here is the harsh reality of the 0625 syllabus. Knowing the physics and knowing how to extract maximum marks from the examiner are two entirely different skills. The pressure is on. You've got to break down the story of the question and deliver a headline answer that leaves absolutely zero doubt in the examiner's mind. So many students lose incredibly easy marks on this alpha particle scattering topic, specifically on how the thin metal foil experiment actually supports the nuclear model. It's a tragedy, honestly. But after this explainer, you absolutely won't be one of them. I'm your host, and today we are going to dive deep into the examiner's mind. I'm going to show you exactly what they're looking for, straight from the source. Grab a pen because this is going to be a real game changer.
Okay, let's dive into this roadmap. Here's what we're covering today. 1. The challenge. 2. The strategy reveal. 3. The transformation. 4. Our interactive workshop. 5. Avoiding examiner traps. And finally, 6. The final system.
Section 1. The challenge. Let's get right into it.
So what does this all actually mean? Well, it is incredibly frustrating to genuinely understand a complex physics concept, but still get a mediocre grade when you get your paper back. It drives students crazy. You see, the physics assessment objectives target very distinct cognitive domains. We're talking about knowledge and understanding, application, and analysis. And it is right there, in that final domain, analysis, where the battle is truly won or lost. So ask yourself, why do candidates consistently lose multi-stage analysis and method marks on alpha scattering? Well, the principal examiner reports give us the exact unfiltered answer. The academic benchmarks for this specific topic require highly logical, structured reasoning. The assessment framework explicitly prioritizes analytical depth over superficial breadth. In simpler terms, writing down absolutely everything you know about radiation is not going to save you if you aren't actually analyzing the specific scenario provided in the prompt. Students find these method marks so tough because they completely miss the fact that marks are awarded for the actual process of your reasoning, not just jumping to the final conclusion. They want to see how your brain works.
Let's make this concrete. Let's look at two classic profiles of candidates sitting this exact exam. I guarantee you know someone like this, or maybe actually you've even been one of them. On the left, we have Alex's approach. Now, Alex has studied hard, super hard. When they see the words alpha scattering on the page, they panic a bit and just overload their answer with raw physics facts. They write massive paragraphs about alpha, beta, and gamma radiation, half-lives, decay equations, the whole shebang. But it completely lacks analytical depth. It is the definition of superficial breadth. Then, on the right, we have Sam's approach. Sam is a speedrunner. Sam rushes through the problem because they just want to get to the math section at the back of the paper. Sam entirely misses the specific command word requirements. If the question specifically says evaluate, Sam just states a fact and moves on. Here's the brutal truth. Neither Alex nor Sam is getting top marks. They are literally leaving easy, predictable method marks on the table.
Section 2. The strategy reveal. It's time to fix this.
We need a totally new approach. Let's shift our focus to the core theoretical architecture you absolutely must have before you even think about putting pen to paper. The syllabus emphasizes that top-performing students exhibit connected, conceptual understanding that they can transfer to totally unfamiliar contexts. But, and this is absolutely crucial, before we build that advanced framework, we must solidify the foundational knowledge. When alpha particles are fired at a thin metal foil, the resulting scattering pattern is what supports the entire nuclear model. And this brilliantly illustrates 4 non-negotiable points you have to recall. 1. There is a very, very small nucleus. 2. It is surrounded by mostly empty space. That's exactly why the vast majority of those alpha particles just pass straight through without hitting anything. 3. The nucleus contains most of the mass. That explains those massive, dramatic deflections when a direct hit actually occurs. And 4. The nucleus is positively charged, which causes the direct repulsion of the positively charged alpha particles coming at it. Look, if you don't have these core relationships memorized inside and out, honestly, no exam technique in the world can save you.
So, what is the ultimate solution to stopping this cycle and avoiding the traps that Alex and Sam fell into? It's something called the PEEL framework. That stands for point, evidence, explanation, and link. This structured response method literally forces you to directly answer the exam's specific command words. It ensures the kind of logical, structured reasoning that examiners are practically begging to award marks for. It keeps you on track. Now, before we continue and I show you exactly how to apply this framework to completely transform your written answers, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, awesome. Let's keep building this up.
Section 3, the transformation. This is where it gets real.
Welcome to the procedural framework. This is all about practical, on-the-ground application in the exam hall. You need to develop professional exam skills, applying correct formats, using the appropriate scientific terminology, and dynamically evaluating your own performance as you write. Let's walk through the exact sequence that guarantees method marks. I want you to think of this as your definitive success blueprint. It's an insider secret. Step 1. Identify the key elements from the texts and tables provided. What is the raw data actually telling you? Step 2. Apply the relevant principles. Connect that raw data directly to the nuclear model we just reviewed. Step 3. Execute the analysis with crystal clear working. Step 4. Verify the results against your core physics knowledge. Take a breath and ask yourself, does this actually make sense in the real world? And finally, Step 5. Present it in the appropriate format using comparative connectives and highly specific terminology. I promise you, this kind of systematic processing is exactly what separates an A-star candidate from a C candidate. It's night and day.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams.IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @theexams.IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4, Interactive Workshop. Let's put you to the test.
Okay, let's put that blueprint into action right now. Because knowing the standardized method sequence in theory is one thing, but applying it under the ticking clock of a real exam is a whole different ballgame. I am going to challenge you to extract data and apply the framework under deadline pressure. Challenge 1. Data scan. You have exactly 60 seconds on the clock. I want you to imagine a highly complex physics chart right there on your exam paper. It's showing the scattering angles of alpha particles hitting that thin metal foil. You notice that most pass through slightly, a few deflect slightly, and a tiny fraction bounce almost straight back at the source. Your job in these 60 seconds is to mentally extract the core trend. What is the foundational, undeniable truth hidden in that data? Data interpretation skills are absolutely critical here. You must be able to instantly interpret these relationships and draw rapid, evidence-based conclusions. And time's up. How did you do? The core trend you needed to spot? The atom is mostly empty space, but it has an incredibly dense, positive core. That's the golden ticket.
Now, to execute that successfully in a written, paragraph-style answer, you absolutely must meet some very specific critical analysis requirements. Top-scoring candidates constantly demonstrate what we call evaluative thinking. You have to question the underlying assumptions, you need to consider different perspectives, and crucially, and students mess this up all the time, you must identify similarities and differences when a question asks you to compare. You cannot, I repeat, cannot just list the similarities and call it a day. The examiner will penalize you. Finally, you must justify your decisions with hard evidence. If you evaluate the quality of the evidence, you also have to identify its limitations or suggest alternative interpretations. It's about showing the examiner you see the whole picture.
So, the crucial point here is applying this precise terminology. This brings us to challenge 2, find the flaw. I want you to look at these 2 answers. First, the vague answer. Particles bounce back because they hit the middle. Now look, technically speaking, in a casual, colloquial sense, it's not entirely wrong, but on a Cambridge exam, it earns 0 marks. None. Because it totally lacks professional terminology and analytical depth. It's too casual. Now let's look at the context-specific answer. Alpha particles were repelled, proving the nucleus is positively charged and contains the majority of the mass. Do you see the difference? This one uses highly specific, scientific terms, repelled, positively charged, majority of the mass. It draws a clear, evidence-based conclusion from the data. It follows that Peel framework perfectly. It's a night and day difference, and it is exactly how you secure every single method mark available.
Section 5, Avoiding Examiner Traps. Pay close attention to this part.
Look, even with the Peel framework in your back pocket, students still fall into nasty traps that can literally cost them a whole grade boundary. We've heavily scoured the actual principal examiner reports for the 0625 syllabus to bring you the top mistakes made globally. Examiners are practically screaming these warnings year after year. Warning 1. Answers are often way too vague. Just like we saw in the last challenge, saying something hit the middle is way too vague. Examiners demand specific, scientific details. Warning 2. Candidates frequently forget to check their format and presentation. If a question specifically asks for a comparison, you better structure your paragraph as a comparison. Warning 3. Responses are not specific to the context given. Please, whatever you do, don't write a generic, memorized essay on general radiation if the question is specifically about the thin metal foil experiment. Answer the question in front of you. And warning 4. This is arguably the biggest examiner alert of all. Key terminology is consistently confused. The reports stress this so heavily. You must always define your terms before using them in extended responses. Do not confuse deflection with reflection, and never confuse mass with weight in these specific physics contexts. It's a fast track to losing marks.
So, how do we combat that terminology confusion when you are under immense pressure? Here is a highly effective memory hack directly inspired by top-tier students. You need to create a custom acronym for the factors affecting alpha particle scattering and the nuclear model. For instance, you might use SCEM. SCEM. That stands for small, charge, empty space, mass. Honestly, whatever works best for your specific brain. Having a concrete, actionable acronym like CEM gives you an instant toolkit for rapid recall in the exam hall when the panic suddenly sets in. It forces your brain to remember the specific scientific details the examiner's actively hunting for on the page.
Section 6, the final system. Let's bring it all home.
All right, we are entering the final stretch. Let's bring all these concepts, all these warnings, and frameworks perfectly together into one cohesive master strategy. This right here is where you transform from a stressed, anxious student into a methodical, examiner-pleasing machine. Here is your ultimate cheat sheet recap. The complete physics answering system rests on these 3 simple rules for top marks. Rule 1, command word decoding. Remember our friend Sam? Stop being Sam. Read the specific command word, state, explain, evaluate, compare, and shape your entire answer precisely to it. Rule 2, peel framework application. Stop being Alex. Don't just list 100 facts hoping one is right. Use point, evidence, explanation, and link to create structured, logical reasoning with profound analytical depth. Rule 3, time management matrix. You have to execute systematic processing. Please don't spend 10 minutes sweating over a 2-mark question and then only have 2 minutes left for a massive 6-mark multi-stage analysis. Allocate your precious time based entirely on the method marks available.
So why does all of this actually matter? Because students who implement these exact physics strategies see an average improvement of 2 full grade boundaries. That is literally the difference between a C and an A. It's huge, but, and this is a big but, they only achieve that if they practice consistently and apply this framework to every single past paper they attempt, alongside watching our weekly exam strategy sessions. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at AceTheExams_IGCSE and click that bell. Don't let another exam pass you by.
I want to leave you today with this incredibly powerful benchmark pulled straight from the official Cambridge syllabus. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. That right there is your ultimate goal. It's not just about rotely memorizing the metal foil experiment. It is about deeply understanding the fundamental relationship between charge, mass, and force, so that no matter what incredibly weird and wonderful scenario the examiner decides to throw at you this year, you have the connected concepts ready to evaluate it, analyze it, and absolutely ace it.
So, I want to hear from you. Drop a comment below with your target grade for physics and the biggest challenge you're facing with alpha scattering right now. Our team responds to every comment, and we really want to help you clear those specific hurdles. Like and share this video with a study partner who needs to see this before the exam. Keep practicing that systematic processing, keep applying that PL framework, and we will see you in the next explainer. Ace the Exams, your Cambridge success starts here.